Question number 1. Faraday's law of electromagnetic induction is related to. We know that according to Faraday's law, an electromotive force is generated along a loop such that the generated EMF is equal to the rate of change of magnetic flux in the loop. But we have to understand, when generating an EMF, the work done on the loop is converted into electric energy. Therefore, we can get it is a result of conservation of energy. Then second one is correct answer for the question number 1. In a uniformly charged hollow metallic spherical shell, the variation of electric potential V with distance r from center is best represented by. We can consider, we know that when considering a metallic shell, all charges are spreading in the outer surface, on the outer surface. Therefore, we can observe that there is no an electric field inside and there is an electric field outside of the shell. But when considering potential with distance, potential inside the shell is a constant value because of electric field intensities. Potential gradient, there is no a potential gradient. It means there is no potential difference between this point and this point. After that, we can get potential for an outer point 1/4 epsilon q over r. Then potential is inversely proportional to r. Then graph should be like this. Then we can obtain second one is the correct answer. Question number 3. 3-point charges initially at infinity are brought to the vertices of an equilateral triangle. Out of them, 2 charges each has a charge of plus q. If the total work done due to the electric field to bring the 3 charges to the vertices of triangle is 0, what should be the value to the third charge, value of the third charge? Now I will consider 3 charges at vertices of an equilateral triangle. All 3 distances are equilateral triangle. And there are 2 plus q charges and this charge is capital Q. We have to find capital Q. Potential energy of this charge due to this one is 1/4 epsilon q into q squared over r. And potential energy of this one due to this charge is same. Therefore, we can get total potential energy of these two charges 2 times of this value. Potential energy of this charge due to this one is 1/4 epsilon capital Q simple Q over R. There is the same potential for this one due to this charge and this one due to this charge and this one due to this charge. Therefore, there are 4 potential values like this. Sum is 0. Then we can find capital Q value. I will bring this term to the right hand side. Then we can write minus 2/4 epsilon q squared over r equals q. We have to multiply this value by 4 because of there are 4 same charges, same potentials. 1/4 4 into 1 4/4 epsilon q over r. Then we can cancel out r 4/5 epsilon q 1 q term 2 divided by 2 1 4 divided by 2 2. then we can obtain capital Q should be equals to minus simple Q over 2. Then we can get correct answer is second one. Question number 4. One electron is moving opposite to a uniform electric field E, and another electron is moving perpendicular to a uniform magnetic field B, as shown in the figure 1 and 2. For each situation, the de Broglie wavelength of electrons respectively. We can remember the equation for the de Broglie wavelength. Lambda d is h over p. P is momentum, which is Planck's constant. Then we can get P is the MV product. For the first situation, electron is moving opposite to the electric field. Therefore, electron is accelerating and its velocity increases. When velocity increases, we can observe that wavelength decreases. Then for the first part, de Broglie wavelength should be decreases, and for the second part, electron is moving perpendicular to a magnetic field. As a result of that movement, magnitude of velocity of electron will not change. It will move in a circular path. Therefore, velocity is a constant value. Lambda d is a constant value. It does not change. Then we can get decreases and does not change. Third one is the correct answer. Then question number 5. Two charged particles A and B of mass m1 and m2 and charges q, 2q respectively are moving in a circular path of radii r and 2r respectively. Are moving in a circular path of radii r and 2r perpendicular to a uniform magnetic field as shown in the figure. If the speed of A and B are v1 and v2 respectively, what is the value of ratio m2 v2 divided by m1 v1? I will get the relationship for the m1 v1. We can use F equals ma towards the center. Force is B qv. Mass into v squared over r. mv squared over r. v squared over r is centripetal acceleration. Then we can cancel out one v term and I will subject mv. It is bqv. For both situations, b is constant. Therefore, mv directly proportional to qv product. No, bqr. mv directly proportional to qr product. Then we can get m2 v2 directly proportional to charge of m2 particle 2q, radius 2r. m1 v1 proportional to charge of m1 particle q, radius r. Then we can divide both the equations. We can cancel out q and r. We can obtain answer as 4. Then fifth one is the correct answer for question number 5. Question number 6. Two identical capacitors X and Y are connected by a wire with an open switch K as shown in the figure. Initially, capacitor X is given charge Q while Y is uncharged. Consider the following statements regarding the capacitors after the switch is closed. Part A. The charge in the capacitor X decreases to Q over 2. Yes, when considering ideal capacitors, we can consider that charge will spread separately equally. Then statement A is correct. Statement B. The voltage across capacitor X does not change from its initial value. We can consider Q equals CV equation. When Q is half of initial value, V also half of initial value. C is constant because of C is depending on permittivity of medium, area of one plate and the gap between two plates. We are not changing capacitors. Therefore, statement B is false. Voltage is half of initial value. Then C, the energy stored in the capacitor X decreases half of its initial value. we can write energy half QE. Half is Q is half of initial value, and V also half of initial value. As a result of this, energy should be 1/4 of initial value. Then the statement C also incorrect. Only A is true. First one is the answer. Then question number 7. For a satellite moving in a circular path around the Earth, kinetic energy, gravitational potential energy, and total energy are given by kV and E respectively. Which of the following relationships is true? I will consider, I will use F equals ma towards the center for the satellite. We know that centripetal force is given by gravitational force. It is gmm over r squared, m v squared over r. Then we can cancel out one r term, and I will divide both sides by 2. Gmm over 2r is half mv squared. Half mv squared is kinetic energy. Then this one is the relationship for kinetic energy. Then I will get potential energy. Potential energy is V in the question. We can get V minus gmm over r. Now we can compare these two values. Those are not equal. But total energy should be equals to kinetic energy plus potential energy. Kinetic energy is this value, gmm over 2r. Potential energy is this one. It is a minus value. When simplifying this one, we can obtain mark of the large term minus this value minus this value, gmm over 2r. Now we can identify there is the same value for kinetic energy and total energy, but there is an opposite mark. Then we can get E should be equal to minus k. Then answer is 1 for the question number 7.